In this video, I will show you how to take force data for force curves reconstruction with the Cypher machine from Asylum research. I am assuming you are familiar with this system. Specifically, you should be able to mount a cantilever, do the first and the second calibration as well as take the critical amplitude for the cantilever. Watch our previous videos on these topics. So let us start taking data for force reconstruction. To do this, I will be using a method called smooth transition method. Basically what you have to do in this method is to select a large free amplitude for the cantilever tip so that it has enough kinetic energy to avoid it trapping on the surface of the sample. Selecting large free amplitude will also make it possible to access all the distances on the surface of the sample. So all you need to do is to use 3 to 4 times the critical amplitude. I already covered this topic in an earlier video. But for completeness, I will cursorily go through the process. Specifically, I want to show you some tricks that preserve your tip when finding the critical amplitude. So for this demonstration, I have completed the second calibration and am about to find the critical amplitude. I take a single force. From this curve, you can see that the amplitude decreases and the phase angle are in the attractive regime throughout. So I keep increasing the free amplitude till I get the best stability. The critical amplitude for this tip is about 360 millivolts. To get to the smooth transition, I will select about 1.5 volts, about 4 times the critical amplitude. Because I intend increasing the amplitude to a very large value, to preserve the tip, it is safer to make the cantilever go far away from the sample. I do that by increasing the force distance first. For this demonstration, I increased it to 200 nanometers. And click the single force with this new value. Now I can increase the free amplitude. Before pressing the single force. I also want to adjust the trigger point. Because the amplitude is so large, by the time it decreases to a minimal value of 20 millivolts, the tip would have been damaged. So I choose a trigger point very close to the free amplitude, say about 1.49 volts. Now I can press the single force button. This is the smooth transition curve. That is, as the amplitude decreases, the phase transits from the attractive to the repulsive regime smoothly without a discrete jump. From this curve, I see that I'm only interested in this region, which is about 5 nanometers. So I can decrease the force distance to about 20 nanometers to have more resolution. All that is left now is to give a base name to the force curve. You can do that here. I call it FC graphite. FC means force curve, and graphite because I'm using a graphite sample for this demonstration. You can follow the naming convention in your lab. So I press continuous button now to take a couple of force curve continuously. Note that the data is being acquired at about 1 Hz and a velocity of 36 nanometers per second. I suggest around these values of parameters. Increasing the scan rate will give fewer points for the force reconstruction. This number here shows the number of force curves being taken. About 30 data points will be sufficient for the force reconstruction. So I click the Stop Force button. You can view all the data points in the Master Force panel. You can find it under AFM Analysis. Select your choice directory to save the data by going to the Path tab here, then select Browse. Knowing this path will be useful for collecting the data later for the force reconstruction. In the next video, I will show you how to acquire data for force map reconstruction.